In 5-4, we're going to work with division of decimals. If you don't know how to do long division, I'm going to be doing it for you to watch. If you're not sure, then you need to go visit our friends in the math lab or talk to a 5th grader. They're probably pretty good with long division right now. Or, go on YouTube and see if you can find an explanation of how to do long division. I'm going to try to keep this fairly simple long division. I'm more interested that you know what to do about the decimal point with decimals than I am giving you challenging division problems. So let that be said up front. So when we divide, we have 3 things. We have a dividend that's in the box. We have the divisor that we're taking into this. We're dividing this by the divisor, and the quotient is our answer. If it's written as a fraction, the dividend's on top, the divisor's on the bottom. If it's written with a little elementary school division sign, it's the dividend divided by the divisor. So that might be something that you need to keep in mind. So if you're dividing a decimal by a whole number, in other words, if the divisor is a whole number, you're going to place the decimal point in the quotient directly above the decimal point in the dividend. So if it's here, it goes up here. Simple as that. And then you divide as if you would whole numbers. So let's look at the first one. We have 502 and 96 hundredths divided by 8. So we're dividing by a whole number, so our decimal point's going to go right here. Now we're going to go through each place. We're going to go through each place and do our division. 8 will not go into 5, it goes into 50 6 times. 6 times 8 would be 48. So we've divided, we've multiplied, and now we're subtracting, and now we're bringing down that next number. And we start again. How many 8s are in 22? Well, 2. And we're multiplying. 2 times 8 would be 16, and we have 6 left over. Now we're going to bring down the next number. How many 8s in 69? And you can use a multiplication chart for this. 8. 8 times 8 would be 64. That's as close as we can get to 69 without going over it. Subtract, bring down the next number. How many 8s in 56? 7. 7 times 8 would be 56. And we're finished. No remainders at this point. Okay, let's look at this one. We have 2 and 7 hundredths divided by 3. We are dividing by a whole number. So this decimal point just jumps up for the quotient. 3 won't go into 2, it goes into 26 times, because 6 times 3 is 18. We have 2 left over. We'll bring down the 7. 3 goes into 27 9 times, because 9 times 3 is 27 with nothing left over. So we're done. This is our quotient, this is our quotient, and we're done. We don't usually have remainders when we divide with, when we're doing division with decimals. We either add decimals until we don't have a remainder, or in a moment we're going to be rounding the answer to a particular place depending on what kind of an answer that we need. So let's do this one. 10 and 2/10 divided by 4. Here's the decimal point, it goes right here. 4 won't go into 1, it goes into 10 2 times, because 2 times 4 is 8. We have 2 left over. We'll bring down the next number. This will not go evenly, because 5 times 4 is only 20, and we have 2 left over. So what we're going to do is we're just going to add another 0 to our dividend, and now we'll bring it down, and now 4 goes into 25 times. 5 times 4 is 20, and we're done. It's come out even. We keep dividing until there is no remainder, unless they tell us about rounding, and we'll talk about that in a moment. Okay, this problem is -6 8/10 divided by -5. We are dividing by a whole number, so the decimal point just goes above where it is in the dividend. Signs are the same, so the answer is going to be positive. And now let's divide. 5 goes into 6 once. 1 times 5 is 5. With 1 left over, we'll bring down the 8. 5 goes into 18 only 3 times, which is 15. 5 times 3 is 15. We have 3 left over. We're going to add another 0. And we'll keep adding zeros until it comes out even or they tell us to round. How many 5s in 30? Well, daggum, there's 6. 6 times 5 is 30, and we're done. So if we're dividing by a whole number, then we just, our decimal point just appears right above where it is in the dividend. Now, we are going to have repeating decimals sometimes. Sometimes that number will continue in our quotient, sometimes like a decimal point, then 66666666666. If I did it on my calculator, my calculator at least would round that last digit so it's a 7. But we're going to have repeating decimals. To denote the repeated pattern, use a bar over the first occurrence of the repeat cycle to the right of the decimal point. So this is what they're talking about. If you had this and it continued forever, then we would write that with the bar over the 3 because it's the 3 that continues to repeat. If we had something like this, and it continues, then we would write that it's the 9-4 that keeps repeating. So we write it once and put the bar over, but we do have to remember that we have a 2 there. So that's what they're talking about. So here we go. Let's divide. We have 1 7/10 divided by 3. I'm dividing by a whole number, so I know the decimal point goes right there. 3 won't go into 1. It goes into 17 5 times, which is 15. We're left with 20. And again, we're going to be adding zeros. 3 goes into 26 times, which is 18. We're left with a T. We'll continue to add zeros. We brought this one down, and now we're bringing this one down. It goes 6 times, which is 18. Do you see what's going to happen? As we continue to add zeros, we're going to keep getting 6s because we're going to keep getting 2 left over each time. So we would write this as, I'm going to think of a 0 here. We're going to write this as 5, decimal point 5, 6, and the 6 is what's repeating. This is what's repeating, and that's where the bar goes over the 6. Let's do one more. 2 4/10 divided by 9. We know the decimal point's going to go here because we're dividing by a whole number. 9 won't go into 2. It goes into 24 2 times, which is 18, with 6 left over. We want to keep carrying this out, so we'll add a 0. 9 goes into 60 6 times, which is 54, with 6 left over. Oh my goodness, do you see it's going to happen again? We're bringing down the next 0. It goes 6 times, which is 54, with 6 left over. No matter how many zeros we add, we're going to have the same thing. It's going to repeat this. So we're going to write our answer with the bar over the 6 because it's the 6 that continues to repeat. Now, every time we've divided up to this point, we have had a whole number as our divisor. Now we're going to be dividing when the divisor is not a whole number. In other words, we're going to have a decimal place, some decimal places out here in the divisor. What we're going to do is we're going to move the decimal point in the divisor to the right to make it a whole number, and then we know what to do. Well, if we move the decimal point in the divisor, we have to move the decimal point in the dividend to the right the same number of places as the first step. So we're making the divisor 10 times bigger, we'll make the dividend 10 times bigger. Or make the divisor 100 times bigger, we'll make the dividend 100 times bigger, and our quotient will stay the same. Once we do that, we're doing what we've been doing. We're going to place the decimal point in the quotient directly above where the decimal point now is in the dividend. And then we'll divide as we would with whole numbers and be sure that we have the correct sign. You know, if they're here, we've got different signs, so we know that we're going to have a negative quotient. Here, signs are the same, so we know we're going to have a positive quotient. Okay, so let's get this set up. We're going to have 56 hundredths, and we're dividing by -7/10. So we're going to move this decimal point in the divisor so it's a whole number 7. We're moving it one place. If we move this one place, then we have to move this one place. And now our decimal point's going to go here in the answer, and we're dividing 5 6/10 by 7. This is the whole number 7. 7 won't go into 5, it goes into 56 8 times. 8 times 7 is 56, and we're done. -8/10. This one, we have 3 1/10 divided by, oh my gosh, 5 10,000ths. We're dividing by a decimal, so we're going to have to move this decimal point to the right until we have a whole number. We've moved it 1, 2, 3, 4 places. So we're going to have to move this decimal point 4 places to the right. Here's 1, 2, 3, 4. This is where our new decimal point goes, and it's here. So now we're dividing this number, 31,000, by 5. This is the whole number 5 now. So 5 goes into 31 6 times. 6 times 5 is 30. 1 left over will bring down the next 0. 5 goes into 10 twice. 5 times 2 is 10. We don't have anything left over. We'll bring down the next 0. Nothing. Bring down the next 0. Nothing. And we're done. 6,200. And I'm not surprised. In a little over 3, these are itty-bitty numbers. There's lots of these in 3 1/10. We talked about multiplying by powers of 10. Now we're going to divide by powers of 10. When we multiply by powers of 10, we move the decimal point to the right, the number of places that there were zeros. So to divide by a number by a power of 10, we move the decimal point to the left, the same number of places as there are zeros in the power of 10. So if we want to divide this number by 10,000, how many zeros are there? 4. So we're going to move this decimal point 4 places this way. 1, 2, 3, 4. If we're going to divide this by 100, we have 2 zeros, so we're going to move this decimal point 2 places to the left. Here we're dividing this number by 10, so we'll move this decimal point 1 place to the left. And if you like that little courtesy 0 out there, there you go. So now let's talk about rounding these quotients, these answers. You know, sometimes the repeating decimals are useful and sometimes they're not. Sometimes we want, you know, maybe we just want, if, for instance, if this were money, oftentimes we just want dimes and pennies. We want 2 decimal places. We want hundredths of a dollar. So if we're going to round to the nearest hundredth, our answer is going to look like this, which means we're going to have one more place out here, and this digit right here tells us whether to stay the same here or whether to go up. So let's look at this problem. We are not dividing by a whole number, so we need to make this a whole number. We're moving the decimal point one place to the right there, so we have to move it one place to the right here, and that's where our decimal point goes. To round to hundredths, we're going to need 3 places, so I'm adding 3 zeros beyond the decimal point, and then I'll be able to round it to hundredths. So how many 9s in 3? Or well, how about 32? How about 3, which is 27? We'll subtract. We'll bring down the next number. How many 9s in 51? There's 5. 5 times 9 is 45. With 6 left over, now we'll bring down the 0. How many 9s in 60? 6, which is 54. Wish I had a little more room. 6. We'll bring down the next 0. And again, it goes 6 times, which is 54 with 6 left over. Do you see the repeating part? But it doesn't tell us to show the exact answer, which would be the repeating part of it. Instead, we're going to round it to here. So we look at this next place, and it's a 6, so we're going to go up. So this answer is approximately 35 67 hundredths. That would be the correct answer. This time we're going to round to the nearest tenth. So our answer is going to have this, but we'll have to carry it out one more place so we'll know how to round back. Oh my goodness. Again, we're dividing by a decimal, so let's make a whole number. We're moving it 2 places to the right. We'll have to move this 2 places to the right. So our decimal point is going to go right here, right above the space between the 2 and the 1. So we're really dividing by 8. 8 won't go into 0 or won't go into 3. It goes into 32 4 times, which is 32. Nothing left over. We'll bring down the 1. There aren't any 8s in 1. So now we're going to have to add a 0. This is the only one we have to add because we have to have 2 places in our quotient. How many 8s in 10? Only 1. And we're done because we have 2 places and we're rounding to the 10th. So we have to look at the neighbor. It's only a 1, so we're just going to drop it off, and our answer is approximately 4.0. This is the 10th place, and we need it there. So now, what do we do if we're asked to round a repeating decimal? Let's take a look. We're going to write out enough of the repeated pattern so that we can view the digit to the right of the rounding place. So I've worked out the problem. So these are the answers. So we know what this looks like. The 4, 5 continues to repeat, doesn't it? And we're asked to round it to the nearest hundredth. So we're rounding it to here. We look at our neighbor. It's only a 4, so we're going to drop all this off. So this is approximately 45 45 hundredths. So let's look at this. We're rounding to the nearest thousandth. So I'm going to write this pattern out, probably just once in this case. We're rounding to the nearest thousandth, tenths, hundredths, thousandths, and we look at the next place and it's a 3. So we're just dropping this off. So this answer is approximately 2 385 thousandths. We have a little application here so that we know that this might be useful. Suppose a lunch cost $45.80 and the bill is to split equally among 5 people. So we're going to divide that by 5 to find out how much each person would pay. We know that this decimal point is going to go right here. And now we're dividing by 5. Won't go, it goes into 45 9 times. Bring down the next number, because this is 0. It goes once. We'll bring down the next number. And we're done. So each person is going to pay $9.16. Then you'd have to add tip, la 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 la. Anyway, at an international track meet, the winning time for the men's 400-meter run was 43 2/10 seconds. What is the speed in meters per second? Round up 1 decimal place. Round to 1 decimal place, the tenths. Okay, so we want to divide, we must divide the distance in meters by the time in seconds. And a calculator would be real handy. But what we know is the decimal point is here. We're dividing by a decimal. So if we were doing this by longhand, long division, we would have to add a 0. But I'm going to do it on my calculator. I'm going to do 400 divided by 43 2/10. I'm going to do the original problem. And this is the answer that I got. Can you see that? The answer that I got was 9.259259, and that is a repeating decimal, isn't it? But we want to round it to the nearest tenth. We look at our next door neighbor, it's a 5, so we're going to go up. So it's going to be 9 3/10 second per meter. Second per meter.